Riley BOABC is the owner of Focal Engineering, an energy modeling consulting firm based in Victoria. He has 10 years of energy modeling experience. Riley has provided energy modeling consulting services on a wide variety of building types for various purposes. He's also an executive member with IBPSABC, which he'll describe in more detail to you what exactly that is. It's the International Building Performance Simulators Association. And he was also involved in the development of the STEP Code and City of Vancouver Energy Modeling Guidelines. So primarily for Part 3 buildings, I presume? Yeah, so take it away, Riley.
Thank you. Good morning, everyone. So yeah, I've been doing energy modeling for around 10 years, seen a lot of change, particularly lately with the uptake of the STEP Code. So there's a lot to cover in energy modeling. I mean, at 10 years of doing it, I'm still trying to figure it out myself sometimes. So I kind of feel for you guys as the building officials is now having to administer these STEP Code targets in your municipalities when there's, of course, a ton of information that goes into it. So the whole idea today is about just trying to give you guys a bit of a general background on energy modeling. There's going to be a lot of information, trying to distill that down into an hour and a half. But we're going to try to give you at least some sense of what goes on at the consultant side of things and the design team so that maybe you can ask some better questions or better understand the submissions that you're receiving. So this presentation is kind of a follow-up to some educational content that we created for BOABC around the Building Energy Step Code. So, of course, energy modeling being a key component of that, this is something that definitely very relevant knowledge. So we're going to go through some learning objectives, some basics about what is an energy model, without going too deep on that. How does that work exactly? We're going to look at specifically how a modeling consultant would work with the design team to create a model, both for Part 3 and Part 9, because there definitely are some differences there. We're going to look at different software that you might see, just so you can understand maybe some of the differences between the two, or the various options and some of the limitations and strengths. And then, of course, we're going to talk about qualifications, and I think this is becoming extra relevant for you building officials. I was just in the session before this, and it seems like there's a very valid concern as to the, can you guys hear me? Is this mic on, or? I think it was cutting in and out in the morning, the first session. I can't get any shorter. Oh, there we go. I'm taller. I'll just do a wide stance. Yeah, so the qualification, oh, it's gone again, isn't it? Test. Well, I guess I can just yell. Anyhow, yeah, so the qualifications is quite important because with your role, I don't think anyone can rightly expect you to fully review, a detailed energy submission. At some point, you have to rely upon some qualifications from whoever is submitting that, and that they are, yes, signing off as a registered professional or as an energy advisor, that yes, they have carried that out correctly. So the things we'd like you to leave here with today are just some general ideas of energy modeling. So giving you an example of what kind of end uses you would tend to see from energy modeling results, maybe how some of the inputs in the model might affect those end uses, some of the basics about the inputs and the methodologies for modeling for Part 3 and for Part 9, describing a little bit of the application of the thermal bridging guide, which is fairly complex in itself, but we'll touch on that. We're also going to look at, we're going to review some, look at what you would look at to review some submissions for energy modeling results. And then, of course, there's benefits around energy modeling, and so understanding how that works is also relevant. So we'll just start out with the basics. Like why are we even talking about this? Why is energy modeling such an important part of the STEP Code? And we'll also look at the metrics that are involved. And really, this is all just about, I'm sure you're very familiar with STEP Code by now. If you're not, you will be shortly. the step code is a performance-based code. So rather than telling someone, prescriptively, here's how you need to have your windows and your mechanical system and your lighting, ultimately, if you can achieve a building that performs in a certain way, we don't necessarily care how you get there. I mean, of course, there are other requirements, but it's a really nice code from a designer standpoint, because you have flexibility to do what you'd like to do. If you want to do something innovative, you can do that and get credit for it. So maybe it's something you couldn't have had credit for under a prescriptive path, but you can using a performance-based code. And ultimately, that's what we're after. So this is, of course, from the BC Building Code, and we have noted here. Sorry, I don't have a. If anyone could grab me a laser pointer, if you guys have one back there, that'd be awesome. If not, no worries. Okay. So of course we have the total energy use intensity. This is a requirement. This is your total annual energy of the building per unit floor area. Pretty straightforward. Then there's also the thermal energy demand intensity, so the TEDI. This is an interesting requirement. This is basically looking at the heating load of the building per unit floor area. So why do we have both? Well, there's a concern, and it's a valid concern, that if we only look at energy use, that we may be relying too much on complex mechanical systems that may not necessarily perform well over their lifetime. They may be prone to not performing as designed because they're complicated. They have equipment that can wear out, that can have control issues. Whereas if we put some more of the onus on the building envelope and passive measures, then that is very, very predictable, very reliable energy performance. So that's for part 3, you have those 2 requirements. For part 9, you have similar requirements, but instead of a total energy use intensity, you have a mechanical energy use intensity, so the MUI. So this is just stripping out the energy for lighting. Oh, there we go. There's another metric for part 3 buildings primarily that is overheating, and we're going to talk about this a little bit more later. Basically, this is some sort of a check to make sure that buildings are not going to be too hot for occupants, particularly residential buildings in the southwest of BC. We're going to talk about this more later in this presentation, and then also there's another session at 3 o'clock that I'll be talking about in more depth, specifically about overheating issues. Okay, so what is an energy model? Let's just get into the nuts and bolts of it, and how do we apply that for step code? So if you want to design a building and you wanted to design it to have a certain energy consumption, unless you build a model, there's no way for you to know that. I mean, traditionally, you would design the building, you have some idea of the performance of components that you're putting into that design, but there's no way to actually know what that building would use for energy. So with an energy model, we have a computer program that has all the heat transfer and all the physics involved in how a building actually behaves and all the systems, and we can simulate that building. We can build it virtually and operate it for a full year of weather data. And we end up with energy use. Now this is important that it's an estimate of how much energy the building will use. It's not a prediction, it's a bit of like a measurement, an evaluation. And this is a little bit more about why it's an estimation. We have a lot of information. So if you think about a real building, you have the site and the climate, you have any adjacent shading from buildings or landscaping, trees, a mountain. You have the local weather. You have architectural inputs. You have the building geometry, of course. The envelope's thermal performance. How the building's assemblies are created. Envelope air tightness. So not only how the envelope air barrier is designed, but how is it installed. You have internal gains. For every single space in our model, we have to define the number of occupants, the total lighting power, how that lighting is controlled, and an estimate for the plug loads. So just general electrical use like computers, etc. And there's a very interesting or very sort of highly variable input there, which is schedules and profiles for those. So let's say for this room, for example, maybe it's designed for, 100 people. Well, if we're going to model this room for a full year, how often is 100 people going to be in here? We don't know. I mean, there's some ideas about what a typical conference room would look like, but we really don't know. So then we have, of course, all of the HVAC and plumbing systems. So You have a bunch of loads in the space, you have a building envelope, you have a climate acting upon that, you have a resulting heat transfer to and from the space that results in either a heating load in the space or a cooling load. So then your HVAC system will respond to that and condition it, and of course deal with ventilation and domestic hot water heating loads. So in short, there's a lot of information that goes into a model. It's very tedious, but it's kind of fascinating too. So many of our modeling inputs, we know. We know the adjacent shading. We know things like the building geometry, the envelope thermal performance. These are sort of predictable things that we can design, and as long as they're built and installed as designed, then we have a very good confidence that this is how they will actually behave. But there are more inputs in your energy model that are sort of estimated. We simply can't know. So the climate, for instance, climates are different from year to year. It's changing, so there are changes regionally as well. We pick climate files from some select locations, but there's sometimes some pretty big distances between locations, and if your project is located there, the climate in that location may be different, but we don't have data for it. Number of occupants, like I discussed for this room as an example, similarly with plug loads. And you might know how much stuff is even installed in a room, but how is it operated? Who knows? So that's where the schedules and profiles come in. Domestic hot water loads, again, it's a very user dependent and occupant behavior input. So really depends on how the occupants are using hot water. So the key thing I wanted to get across here is that these inputs that are variable and kind of unknown, they're estimated based on research. We have some standards that we rely upon that tell you, say, how many people are in a typical conference room, or how does that, how does the lighting energy use vary throughout a day in a residential suite? And they're based on research, so they're a pretty good estimate. But the important thing is that they're standardized. So the step code targets were determined using energy models using these standardized inputs. So it's almost like a miles per gallon sort of rating for a vehicle. You are going to buy your vehicle based on, maybe your fuel economy rating. You're not expecting it to actually perform like that. That's only under a sort of an apples to apples comparison, so that you have a standard benchmark for which you can compare different vehicles. It's the same thing for the step code for buildings. So when we're modeling our buildings for step code, in some cases, even if we know maybe something particular about that building that might behave a little bit differently than the archetype building that was used, we'll still use the standardized inputs because we're trying to do a comparison using this set of modeling rules rather than trying to accurately predict the actual energy use of the building. Also, we don't have a lot of people in here, so if anyone has any questions, feel free to put up your hand. So the key takeaway here is that if you're modeling for step code, you must use the standardized inputs. For part 3, this includes the City of Vancouver Energy Modeling Guidelines, the NECB 2015 Part 8, which has a bunch of background modeling guidelines about how certain things should be modeled. I threw a note in here that there may be some exceptions in some cases. I think some people might be uncomfortable with me throwing this in here, but I think that if you have a one-size-fits-all solution, inevitably you're going to run into situations where it doesn't fit. One example I have is affordable housing building. So we're using this, we're modeling against a standard multi-use residential building, but then our building has a commercial kitchen in it because there will be meals provided for the people living there. That's a huge heating load, especially for the size of the building because it's fairly small with the kitchen ventilation. The archetype building didn't have that in it, so it's not necessarily fair for us to compare directly against that. And so in some cases, we've actually had to show that we simply actually couldn't possibly meet your TEDI of 15 for your step 4 for residential with this kitchen. It just simply doesn't work. And so in some cases, we might need to look at situations where the particular building has a situation that may be something that you need to exclude or have an exception for. Shouldn't be typical, but I think it's inevitable with having broad building archetype targets. Every building is going to be a little bit different. And then, of course, for part 9, you have energy performance compliance modeling rules. Most of this is going to be following EnerGuide, HOT 2000. I think that's almost all of the submissions for Part 9 energy modeling. Admittedly, I don't work in Part 9, so if it seems a bit thin on content here, that's why, but still happy to answer any questions I can. So the main thing, though, is that if you're receiving submissions for step code with energy modeling, then just the bare minimum, I think, would be that you have reports that list, yes, these resources, these methodologies, these requirements for how things should be modeled, they were followed. Okay, so how does this actually look in practice? So here's a lovely Part 3 building we've been working on recently. We build up a model, so we get some architectural drawings. We build this model ourselves in our software. It's a specialized software. Sometimes you can import geometry. It doesn't work great. The softwares don't talk to each other that well, but just to give you a sense, like we do represent the geometry accurately for the purposes of doing proper solar shading calculations, proper daylighting, and of course heat transfer. And the overall process from a design team standpoint is, we build the model, we gather all that information from the design team. What do we want our building to look like? What's the mechanical system going to be? What kind of wall assembly are you looking at? Window specification. Then we run the model, we get results. We have all sorts of results to look at, and this is where we compare these results against whatever target we were trying to achieve. And the beauty about this is that then we can iterate. Once we've taken the time and effort to build a model, we get some idea of the profile of energy use in that particular building and with how we've designed it. We take our estimates and our first cut, try to get to where we want to be, but we may find that the building is overachieving. Okay, well maybe there's some opportunity for some cost savings here. Or maybe it's underachieving. If so, what are the best opportunities to improve that? And we can look at individual changes to the model and try to iterate and get that going. And to me, this is one of the biggest values of the step code, is that it is now bringing energy modeling into almost every project. I mean, there's step codes being widely adopted. So now you'll have these energy modeling done already. So now you're going to be more likely to use this as a design tool, and I think you're just going to get better design decisions made from them. And of course, then finally, there's a very lovely model report for you guys to read and enjoy. And then from your perspective, at least this is how I see it, I'm imagining this is what happens, is that then you need to know that you need to have some sort of confidence that, yes, what is shown in this report matches these drawings. It's a big ask, but ultimately I think that's the kind of the task at hand, is to say that, yes, this report says that these set of drawings, this design is shown here, it has this performance. There's a lot in between there, but that's the idea. So the sort of inputs that we would include in a report from ourselves would be along these lines. We have some general information, where is the building, what climate file are you using, the design temperatures, software used, all very basic information. There are some pretty good guidelines on what should be included. We actually put together a sample energy modeling report template for BC Housing. I think that should be available publicly, but it would be a good guideline that you could ask people to submit. Oh, also, there was in the session before this, there's talk about a provincial tool, an Excel tool for reporting on energy modeling results. I think that's a great idea to have a standardized report that would sort of have checks and balances to make sure that, yes, the standard was followed. This piece of information is in the same location on all your submissions, so you can find that. I think that makes a lot of sense. That isn't there yet, so this is just an example of what we would provide. This is something you might see where you have your internal gains on for each different space type. Every different space type in your model is going to have a different lighting power, plug load, occupant density, and different schedules of how those vary throughout a day. Of course, information about your building envelope, and so on and so forth. We try to be as descriptive as possible, and so we're always trying to put a reference for where the information came from, so that not only you can go and check that if you wanted to. If you thought, hey, I don't know about this looks a bit fishy, you could go and maybe reference that drawing. We want to make it easy on you. But also for ourselves. I mean, we work through a project and then down the road, we get a question about some sort of input we used. It can be difficult sometimes to try to figure out, well, where did we get that information? Why did we model it that way? So we try to keep a good record of that. Just more envelope stuff, descriptions of mechanical systems. As best as we can, we try to describe the inputs, where the information came from, and what was put in the model. Yeah?
All the modeling you're doing this prior to the other professionals doing their work, and then you give them the information, because like I say, for lighting, the electrical, society wants to bring something different in that skews your results.
Yeah, great question. So in terms of the general process, municipalities like Vancouver, for example, they require a model at rezoning. Well, you haven't designed your building, so what do you do for these inputs? Or even just for projects in a regular step code stream, you're going to require a detailed model at building permit, but before you get your design that far down the road, you want to have some confidence that you're on the right track. So absolutely, we need to do preliminary modeling. And when you do preliminary modeling, a lot of those inputs are based on discussions with the design team. They're based on estimates from ourselves, recommended to the team based on our experience with this building type. We'd say, for instance, we suggest things like, how about this much 20% below ASHRAE 90.1 for lighting power density and occupancy sensors in these rooms. Send that to the electrical engineer. They say, yep, that sounds good, except maybe this space, that might be a bit low. Maybe it'll be 8 watts per meter squared instead. Sounds good. Similarly with the envelope, we don't necessarily know how that assembly is built, but we can just use generic R values to start out with. We can say, okay, let's target a R20 effective wall. And let's just start with that and see what happens. And then we can design to achieve that after the fact. So then once we've done our inputs, we've built our model, we have results. This is again just an example of how we present results. You should have a pretty clear breakdown of the energy end use by utility and by the type of usage. This particular example was a part 3 residential building, so it was a step 3, I believe. Yeah. So the TUI value that we were talking about before, at the bottom there, and the TEDI value, and so of course we met both of those for this particular model. We like to show graphically results. I think that's always important. It's very easy very nice way to display data. So in this case, the TEDI value was just under the 30 mark, and which was our most stringent requirement. And then the TUI was well under the 120 cap. You may also see some charts with monthly end use, just so you can sort of see a bit of a breakdown of how the energy use varies throughout the year. This is something that's not necessarily required. BC Housing has started to ask for this. I don't recall if Vancouver does. I think it's generally good practice if we are, it's useful in the design phases, and so we're usually doing this work anyways, where we try to extract from our model and tease out the different contributions to the TEDI from all the different components of the building. So we have, in red we have the envelope, and then we have the subcomponents of that with infiltration and then ventilation loads. It's a pretty useful tool for us to then go back and say, well, we need to find, reduce our TEDI by 5. Where are the opportunities there? So we could let's say look at infiltration and say, well, our infiltration, we've already targeted something really quite aggressive, so no room to move there. Okay, let's move on to the next area. What else can we look at? So I included this little example here just to sort of underline the difference between TEDI and TUI. So this is the same project, but with heat pumps used for heating versus electric baseboards. There's a little bit of gas used for heating. I think that was a gas-fired makeup air unit for a kitchen. So you have the same TEDI for both electric baseboard as you do for a heat pump. Because the TEDI is based on the heating load, it does not depend on the energy use associated with meeting that load. So again, it's not reliant on mechanical performance, it's purely envelope, infiltration, and your ventilation, including any passive heat recovery from heat recovery ventilators. So Part 3 modeling, a lot of the inputs come from the City of Vancouver modeling guidelines. They're defined there. Those are required to be followed. So I wanted to go over a few of the items that are outlined in the City of Vancouver modeling guidelines just so that you guys are a bit more familiar with them. When the archetype buildings were modeled for residential high-rise or mid-rise Part 3 buildings, there wasn't there wasn't, in some people's opinion, a sufficient ventilation rate to corridors. So as you may be familiar with, in traditional condo buildings, you have pressurized corridors. It's not necessarily a lot of air, but you want to prevent smells from individual suites going into the hallways and impacting other people. So you end up providing some air to the corridor, but you're not providing any avenue for that air to leave, so that it is essentially leaking into people's suites and out through the envelope or through exhaust fans. When you're using that ventilation, by nature, you can't do heat recovery on that. So that's very expensive air. It's 24/7 that you're heating it, and you're not recovering any heat from it. So if you're trying to do that on a building that's trying to go for a TEDI of 15, like a step code level target, that's a real barrier. So the industry pushed back and said there has to be some way to account for this, because this is an important thing from air quality perspective for these building types. And so there is a calculation where you can essentially get a little credit. You can deduct some of your value from your model's TEDI result and your TUI result to account for that. Admittedly, I'm not a fan of this. I wish that this was just built into the target, or that we just changed how we dealt with ventilation in corridors. We maybe compartmentalized suites and dealt with it in a more energy efficient manner, but this is what it is. You may see this on reports. So the thermal bridging guide. This is, for those of you familiar with Passive House, or maybe you're familiar with the thermal bridging guide itself, it's been out for a while. This is basically a methodology to account for a detailed heat transfer in your building envelope. So it used to be that maybe we would just model, what's your effective wall performance? You're including for heat transfer through any sort of studs or framing or Z-girts. That would be the thermal bridging for this, quote, clear field wall type. But then you're looking at additional heat transfer at details. So if you had a parapet or a corner that has more framing in it, or a glazing installation perimeter, the wall doesn't perform as well at those areas. And so we have a method where we can count the heat transfer from those and add that to the wall performance, or deduct it from the wall performance, and therefore derate it and account for it in a more detailed way. This is an example of what that looks like. We do this modeling ourselves because we need that input, so we got on board to start doing this ourselves. So we make these lovely, pretty pictures with rainbows to our walls. And you can see here, this is where a window is installed in I believe this was a 2x8 exterior wall. And so that you can see that the lines by the window here, there's a little bit of additional heat transfer. So the wall down here is maybe like, I don't know, R25, let's say. Here, it's probably more like R18, R20, something like that. So we account for that, and that's required in all of the Part 3 modeling, and it's pretty onerous. Infiltration. There's some good comments about infiltration in the session before this. There is no Part 3 air tightness requirement explicitly, but there is one that is indirect, in that your model results include any effects of infiltration. So I actually like that approach, because, again, it goes back to prescriptive versus performance. If you want to use very tight construction and then very marginal or moderate insulation in your assemblies, if that gets you there, that should be fine. You shouldn't necessarily be reliant on having to achieve a certain air tightness target. So this is in the City of Vancouver modeling guidelines. Excuse me. One thing you may run into, and that we certainly have, we've been reviewing some other people's submissions for other people, is that people have been using this 0.2 value just by default without necessarily understanding what does that relate to as an infiltration rate or as an air tightness leakage rate. So they may use that, say, okay, this is the default, this is what I'm told to use. They go through the project, they end up testing their air leakage at the end of the project and find that, oh wait, actually that was unreasonably low. Oh. Not gonna miss that one. So again, how this works and how we've been approaching it is in preliminary modeling, we need to have a discussion with our design team, with our building envelope consultant, and we say, hey, here's our building. What do we think we're going to achieve for an air tightness testing result? We set a target. In the middle of this is a mid-construction test that we did. We test the building, see where we're at, and then we do a final test, air tightness test, and then we relay that back into the model. So technically in the step code, our understanding, we've confirmed this with the province, is that your final model, once you update that with your air leakage results, it still has to meet whatever step code target you're required to meet. Now, I think that there's some practicality considerations here. Like, let's say it was that big high-rise building I showed you earlier. Are they really going to make them tear all that thing apart and put it? It's just not really feasible, I don't think. So there's some interesting discussions we've been having around the industry about, do you actually have to meet that target at the end? City of Vancouver says it's just informative only, and that there maybe will be actual targets down the road. But currently their standpoint is that people need some time to get used to how do you actually build an air barrier that is going to achieve a certain value. There's just not enough experience in the industry yet. But the approach we've been taking is trying to say, we really want to make sure that we're going to target something that's reasonable and that we're going to achieve it at the end so that we can connect the dots and achieve what we said we'd achieve. So this is a tool that we developed. I put this together for one project. We've been using it as a calculator ever since. We're going to actually put this a version of this on our website at some point. We want to share this with other people. And basically, it's a really simple calculation. It's just looking at relaying various different air tightness testing standards. So ASHRAE 90.1 has an air leakage test requirement of this. It's the same in the VBBL. BC Housing requires this as well. UBC also, although I think they've revised that. Passive house for reference is here. So we have the part 3 air leakage metric is in liters per second per meter squared of enclosure, total enclosure. So that's including roof and floor at 75 pascals. And then when we model, we're modeling it typically in liters per second per meter squared of facade only. So there's a big difference there for low-rise buildings between the envelope, the total enclosure area, and just the facade area. And I think this is where people are getting tripped up. So we like to set a target of about, let's say, about that, and then we use this for our modeling, and then hopefully we get this or better on our project closeout. And you'll note that that's quite a bit higher than the 0.2. We actually had one project where we actually were guilty of this. One of our first step code projects, we've done a few dozen now probably, where we used the 0.2 to start with, and we ended up with testing, and I think it's similar geometry, we ended up with 0.41, even though we met our target for our leakage test. The target for the leakage test was not consistent with the default infiltration rate, and as a result, we didn't meet the step 3 target anymore. Overheating. This one is becoming more and more relevant, I think, with climate change. In particular, there's been a fair bit of research done lately. Ourselves, we've done some work with BC Housing, studying this, looking at future climate. There's work being done at UBC right now that's just about to be published. Essentially, this is defining a maximum temperature per month in the summertime, over which it's considered overheating. The whole idea here is that buildings multi-use residential buildings without mechanical cooling can get pretty hot, and it can actually be problematic, and it can be a health concern for sure. And particularly as these buildings are built now, but with our understanding of climate change, this is going to be more and more of an issue throughout the lifetime of the building. So it's based on ASHRAE 55, which is the standard for occupant thermal comfort, but it's not equal to that. It is not complying with ASHRAE 55. It is loosely related to it. It's using some of the metrics that, or some of the calculations they have. So there's a 200 hours as a base limit in the step code itself, in the City of Vancouver Energy Modeling Guidelines. If you're under the 200 hours, you're good for your worst case suite. There is a line in there that talks about vulnerable occupants. You should use 20 hours. So this would be, people that are elderly, maybe with mental health issues, maybe mobility issues that might not be able to get to a window and open it, or maybe are just have other health risks that they may be more susceptible. So BC Housing, as a result of some of the research that we did with them, they have changed their standard to 20 hours for all buildings. And their whole idea there was that using a 20-hour standard for today's climate will be roughly equivalent to the 200-hour in 2030, 2050 sort of thing. So they're putting the bar down lower, trying to anticipate that. So how do we model this? Well, this is where differences in modeling software can be pretty stark. We use IES Virtual Environment, which is nice software package. It allows you to model operable windows. You can put a control methodology, you can define it as a side hung window, etc. There's wind exposure. So here, all the green ones are operable windows for this particular project. And then we can model that, and we can simulate someone operating in that window based on internal temperatures and external temperatures. So in this example, this is some results from that model in July for one of the suites. So in the blue, you can see this is the outdoor air temperature. So it's, it's 22. In this one day on Saturday, it pumps up to almost 28. One of the hottest days of the year, I think, in this climate file. In the red is the temperature within the suite. And then the black is the airflow from the operable window. So you can sort of see the operable window being used to keep temperatures at a reasonable level. So it's particularly useful to keep this. I mean, you still end up with a suite that's over 29 degrees, approximately 29 degrees in a Saturday evening. And that's actually something I should point out, is that the overheating limits just count 1 hour if you're over that limit. They don't say how far over. There's no limit to the maximum temperature. So it's not necessarily going to say, if you're meeting the overheating limits, like 200 hours, that's not to say that that building's always going to be comfortable. This is more of like a health and safety type thing. So we grab all the results from our model, we spit them out, and we look at what the worst case suite is. So this one was I don't know, we must have had a lot of shading on this building. So you end up looking at the worst case suite, the total number of hours that suite was overheating. That is the value that you report for the whole building. The limits, it's one of the other important thing I should note, is that the overheating limits are defined per climate. So they have them explicitly stated in the City of Vancouver modeling guidelines, but those are only for Vancouver. So if you're receiving submissions and you're not in Vancouver and they have overheating limits that they're stating, there should be some information there about what the limits are that they've calculated for that specific climate zone. So a few key takeaways here for part 3, energy modeling. Does the model match the inputs? Do the inputs match the documents? Again, maybe a big ask from a building official, but if you guys chose to go down that to sort of dig a little deeper, if I was a building official, I would want to be able to do that. I'd want to be able to pick and choose a few things, go through and reference and say, yeah, okay, it's giving me some confidence that the model was done in accordance with the documents. Were the energy modeling guidelines followed? Some real basic stuff here. Corridor pressurization adjustment, was that applied? Was it relevant? Was it a commercial building that they were applying it to, in which case it probably isn't, it shouldn't be applied? Were the infiltration gains aligned with a realistic air tightness? Do they even have a calculation relating the two, or they just use the value and who knows? Was the thermal bridging guide used? And if so, is there any detail on that to give you some idea of whether or not it was applied properly? And then, of course, once you've satisfied yourself that the inputs look okay, well, what about the results? Because the model may not have been carried out itself correctly. Even if they listed all the inputs right, they may have had errors in their models. So do the results look reasonable? This one is pretty tricky, but I think what we'll probably end up seeing if people aren't doing it already, I think the North Van is already doing this, if I'm sure other municipalities are as well, is creating a database with all the step code submissions, and that can serve as a reference, sort of a realistic gauge of whether or not the results that you receive based on the inputs that you're seeing and the type of building, are they in the ballpark? Because if they're not, I mean, that's a red flag right there. Or maybe there's a reason for it, but it should be explained. Are the overheating values defined for the climate? Again, like I was talking about in the last slide. I threw the little note in here at the bottom. I think it would be useful to have, and maybe this will be included in that provincial standard and step code reporting template. Just even a checklist, like version of City of Vancouver modeling guidelines used. Just to force someone to even think about it. I know myself, like doing modeling for LEED or other purposes, there are so many different modeling rules and requirements that I actually find it very useful when I go through the very onerous documentation, because I have to actually go through and check the boxes and say, yes, oh no, that one didn't apply. And sometimes you're like, oh yeah, I forgot about that. And you need to go back and make sure you've addressed that. So that could be a really easy thing, just to make sure that people are looking at all the different things they need to consider and making sure that they're included or not. Okay, modeling for part 9. The process is the same, really. I mean, it's the same thing. It's just different software. It's a different scale of building. You're dealing with a little bit different, probably design process, but overall, it's the same concept. You build a model with whatever you're designing. You run the model, you get results. This is same process as part 3. You iterate that, figure out, are you meeting your targets? So the other nice thing about this is, does the owner want to spend some more money on triple glazed windows? And with a model, you can look at the cost savings of that, right? So they can help them make an informed decision about whether or not they want to spend more money, maybe exceed the targets of the step code. And then of course you get a nice tidy report. In this case, I think it's pretty nice because with the Part 9 modeling using HOT 2000, you have, I think, a fairly standardized report that gets printed out that should be fairly easy for you guys to review, and it should be consistent every time since it's just produced by the software. And then, of course, do the results match the design? Trying to connect the dots. So yeah, again, it's more or less the same, different metrics. We have the TEDI, that deals with the envelope performance. You have the EnerGuide rating, or the MUI. So just quickly on the EnerGuide rating. The EnerGuide rating is a slightly different approach where instead of having a fixed target of, let's say, energy use per unit floor area, you have a comparison to a reference building. And this is something that energy modelers would be very familiar with from Part 3 and Part 9. It's an alternative to the floor area based approach that the step code takes. So here, instead of having a set limit per floor area, you get to build another model, which is a pain in the neck, but that model is then built to the minimum standards, and then you compare your building against that building. It's kind of nice because if you do have some of those weird things, like you're not a standard residential building, you do have something weird going on or non-standard, then that'll be captured, and at least you have a fair comparison. The problem with that is you now have to create a reference building every time. And there's an error margin, and there's potential for error in developing that model as well as the proposed. So when you're comparing the two, you have this compounding effect of, well, if there's one error over here and one error over here, maybe it looks really good, but then maybe you catch that later and maybe they work in opposite directions once you've corrected them, and now you're really in trouble. So EnerGuide rating, I think, is pretty straightforward because it's software generated, but that's how that works. And there's the option to use either or. And then there's, of course, an airtightness testing requirement for Part 9 that you actually have to achieve in addition to the modeling outputs. So the inputs and the outputs, there's a standardized report, like I was saying. Just checking time here. I think I'm going a little quick, so I hope you guys have lots of questions. Any questions so far on that note?
When you're modeling the building, be it part 3 or part 9, you have to take into consideration the changing environment around the building. Say, for instance, that they're projected to be more towers, or you're talking about changing buildings and things of that nature.
Right.
Basically, creation of a snapshot in time. If that's a change in not in the future, is that taken into consideration?
The answer is yes, generally, but often we don't have that information. And I don't, maybe I could be wrong, but I don't believe that that's actually spelled out, whether you have to or not, in any of the modeling guidelines. So the approach that I've generally taken is that if we know with good confidence that yes, there will be a very tall building to the south of that, then we will include that. We may even model it with and without, and it works the other way too, right? Like maybe there is an existing building, but maybe it'll be demolished, right? Like you don't necessarily know, or maybe there's a lovely tree there that's shading this one area, and so you're able to sort of account for that, but maybe that tree gets some disease and has to be taken down, or something like that. Just thinking of one example, we're working on a project at UBC, and there it was nice because it's the same client. They have these buildings that are being designed currently that would be very large, and they will shade our building significantly. So we were able to get good information on the geometry of those buildings and the timing of when those would be. So we have absolutely included those in our model. Any questions about part 9? Do you guys has anyone here ever done any energy modeling? We got one. Okay. How am I doing?
Just 2 or 3.
Okay. Yeah, so do most of you guys deal with part 9 primarily, or part 3? Let's see, like part 9? Okay, so, that's pretty standard, right? Everyone's going to have part 9 buildings in there. Part 3, is it sort of split up? Like, maybe this probably depends on the municipality, but do you have like a part 9 department and a part 3 department? No? Yes. Okay. So some yes, some no. Okay. Makes sense. Seems to me like it's a lot to know all the ins and outs of any particular part of the code, I think. So I find it it seems like a big ask for you guys to be able to know all these things. So I guess this is why we try to give you some high-level background. Yeah.
Do you have an example? If you compare
The results from the report to the drawings? We don't have energy results on the drawings, although we maybe should as per the professional practice guidelines. Are you thinking about are you talking about actual like metered data after the building's built?
Yeah.
Oh yeah, so generally no. It's something that as a modeler we're always very interested in because we want to have accurate models. But at the same time, like I was talking about earlier, if we're modeling using standardized inputs because we're using it under sort of a rating system, then our objective is not trying to predict the energy results. Would it still be very useful and interesting to know? Because maybe we could update those standardized inputs to be more accurate? Absolutely, that would be great. But there's a pretty significant cost. There's a lot of effort to go into pulling data out of a building. The first thing is you need to meter the building quite detailed in order to have an actual useful comparison so that if the energy use is different on a total scale, well, that's great, but where is it different? And so you need to have sub-metering for lighting, for plugs, for fans, et cetera. And that's a pretty substantial electrical cost. We do see that in modeling for lead in some cases because there is a certain credit to encourage that, and then where you have to go back then and compare your building against the actual energy model and update that. And then you can use it as a tool to identify operational issues in the building, which can be really valuable. I will also say too that passive house, Passive House has a lot of research on using their PHPP modeling program to validate their software. So they have done that actively to ensure that their software is a pretty good gauge for your actual building energy use. I mean, of course, every building's different, but on the whole, it's pretty good. So let's talk a little bit about some software. So the common software you'll probably see would be eQuest, I think. I'm not exactly sure what people are more commonly using these days. eQuest is a free software. It uses Department of Energy base code from the US. It's pretty good, but it has some limitations for sure. I used that for many years before moving up to IES. Open Studio is another free software. So this is also based on a US Department of Energy underlying code. That code is Energy Plus. It's sort of the next step from eQuest and the code that used. So that it's quite robust. It can do a lot of things, but it's an open source free software, and so inevitably there are some limitations with the capabilities because it just simply doesn't have the support that a paid for software does. That said, I know some very successful, well-established firms use Open Studio and eQuest, and they're able to provide good value for their clients and good information on that. IES virtual environment, it is probably the most expensive, but it's also, I think, one of the more powerful. Lots of features you can model. It's really nice when you don't have to use a workaround in your modeling program to actually model something. So operable windows, for example, like we find we use that on, projects. Almost every project we're using that because there's a lot of residential development lately. And so being able to model that directly in the software rather than having to do some sort of a workaround and trying to verify, does this actually make sense? And is this an okay, error exchange to simulate operable windows? Well, we can just actually model that directly in the software. For like more institutional type projects, we can do direct daylight modeling. There's a lot of really cool things you can do in that. The things you can't do in that is model your thermal bridging. So your thermal bridging guide calculation still must be done outside. And so you'll have to have some sort of calculation to show that we had an R20 wall, we accounted for all these linear details, and now it's an R10 wall. And once you include it for all those things. We use Flixo. Yeah, so there are generally two software packages for doing evaluating the heat transfer through an envelope detail. They're two-dimensional finite element analysis heat transfer software, kind of fun to use. Therm is free. It's totally sufficient. It's a bit clunky to use. Flixo is reasonably priced, and it's a much nicer user interface. Produces great results. That's the example I showed you earlier of that window detail. We've really enjoyed using it, not just for the details, but also for figuring out the total performance of envelope assemblies, so accounting for the studs and whatnot. We can just model that in there. We don't need to wait on a building envelope consultant to try to give us an estimate. We don't have to look at generic tables. We can just draw it and see what it does. And the nice thing about that is that then we can provide additional feedback on, well, what if we spaced this out or did something a little bit kind of custom? We can evaluate that and see what the effect is. So one of the main things for Part 3 software is that it is hourly or sub-hourly. The requirement is that it has to be an hourly modeling program. So there's good old 8,760 hours in a year, which any modeler will be very familiar with. And you can do smaller time steps. eQuest is hourly only. Open Studio / Energy Plus and IES, you can have smaller time steps. So we typically run I think it's a software default, a 10-minute time step. So you have 87,000 data points for every space in your building, every surface. You can get huge data files, which can be a bit of a endless warren of data, but can also be super useful if you're trying to do some very specific analysis on something and understand how something's working and how you can improve upon it. So again, talking about the differences in capabilities, natural ventilation very useful, particularly for modeling passive cooling for operable windows or for commercial buildings who are using a engineered natural ventilation system with, like, let's say, a central atrium with a relief and operable windows on the sides. The shading analysis is really detailed, which is very, very key, and daylighting as well. So the other software that's listed for part 3 here is Passive House, Passive House Planning Package. This is, I think it's a little bit controversial in the modeling community because it's a glorified spreadsheet. It's very, very well done. It's very well validated, but it definitely has some limitations. So I have some reservations about applying Passive House Planning Package for a larger building because it is, in a sense, a single zone model. So if you have a heat gain on your south face and it's in the September, let's say, so the sun's shining, heat gain on the south side, and you have heat loss on the north side, it just seems that they just offset, which is not necessarily the case. Maybe for a small building like a house, a single family home, that's okay. But for larger buildings, that starts to really break down. There's also some concerns about overheating, particularly with passive houses with the high levels of insulation and design for solar gain. I mean, they shouldn't be, but not in summer anyways. But they don't have that level of detail. They don't have that resolution of hourly data to properly evaluate the comfort in a space. So what we've been doing is, because we do passive house consulting as well, so not just ragging on it here. It is a good tool. It's just that it does have limitations. It's good to understand what those are. So if you're receiving a submission that's saying, yeah, the passive house planning package says that we're fine, overheating is, this, you might want to ask some more questions about that. Lots of consultants are doing an hourly model in addition to the passive house model, just particularly to look at overheating issues. Any questions about software? So for part 9, it's generally HOT 2000. It's a fairly simple program. I've dealt with it a little bit, but not much, just kind of checking it out. It'll automatically build your EnerGuide reference building, so it's very convenient that way in that you could model your building and just submit, and it'll just give you a standardized report and tell you where you're at. With using the modeling for part 3, you have to, there's no step code built into any modeling program. So you have to extract your results, process them in such a way that you're using them to evaluate them against the step code metrics. You have to define what floor area is actually your modeled floor area. What do you use? Like, do you include the parkade or not? Or this storage room that's here, is that conditioned or not? Do you include it? HOT 2000 would be just straightforward. Model it, go for it. Passive house planning package, again, it's, I think, more suited to a smaller building like a single family home. So I wouldn't have any reservations about using that for part 9 buildings whatsoever. Again, aside from potentially some overheating concerns. Now, I believe there's another approach. I don't know really how widely it's used. I know of at least one consultant who does this. And that's using an hourly modeling, using 936. And actually, Andy, now that you just showed up here, have you seen anyone using hourly modeling software, like not using HOT 2000, but using the modeling guidelines in 936?
I think that's too, but very restricted what we require.
Yeah.
A lot of out-of-office models are coming in like a carrier software model that's
Okay.
recently and some other. Able to making up their own kind of parameter software.
Oh.
Which was confused, obviously, but
Yeah.
it didn't know anything to do with step code.
Right.
So I was kind of curious what they were modeling, but it's more like a carrier software. It's very odd. It didn't model any petty parameters, only UV parameters. So it's, yeah, you met some part of it, but not all.
So does HOT 2000, I actually never used HOT 2000, does it actually produce a TEDI value?
Yes.
Oh, really? Or is it to have a heating load that you then have to divide by something else?
No, you put basically the envelope design, and there's quite like 400 tabs that you tick.
Oh, I see.
Varying assembly types, and each sort of elevation assembly assembly has to be run differently, so you get teddy guides for each sort of elevation.
Oh, interesting.
Depending on your window to wall ratio, depending if it's north facing, depending on like your overhang, so you can put so many parameters to get each elevation.
Right.
There's a lot of elevations that face the mountains that have 60 to 70% glazing that are going to perform obviously different than the north facing wall that's got one window.
Okay. Thanks. So yeah, there are other valid pathways that are allowed, but I believe that they're fairly uncommon. So qualifications. This is, I think, a fairly hot topic, I would say. I presented at this conference last year, and there was a discussion, and it ended up being a pretty spirited discussion around who can use HOT 2000 and who are these people and do they know what they're doing. And I think it's a valid concern, really. I mean, ultimately, like we were saying, like there's so much that goes in, as you can see, to these models that it's not really feasible or realistic to put it on you folks to actually dig in and say, yes, this was all done properly. So at some point, we need to rely upon someone having the proper certifications or training so that you can have some confidence in that yes, they know what they're doing. Someone has said that they know what they're doing. So for part 3, there are the whole building energy modeling guidelines or modeling services. This is a professional practice guideline. It's a joint guideline through AIBC, the Architectural Institute of BC, and EGBC, Engineers and Geoscientists of BC. It does have some really useful outlines of requirements, things that should be done, but ultimately it doesn't really have any teeth to it. So you're not required to do this. This is not part of a reporting requirement. This is a guideline. So maybe this is something that a municipality can have some sort of a form to say, yes, we have followed the professional practice guideline requirements, these key parts maybe, as to like who's doing the actual modeling and who's responsible for it, who's signing off, what are their qualifications. That's generally what the modeling guidelines are about. They do have some also some content relating to what sort of information should be provided. For example, you should have your climate zone and your weather file stated and software version, etc. So it's kind of like a best practice guideline, but yeah, it's not necessarily an enforceable thing at this point. So I believe I'm out of date on this. So I said there's still no Schedule B for energy compliance. And in the previous session to this, I saw that there are some new Schedule Bs with some tick boxes for step code. Thing is that I looked them up while I was sitting there, and there's still no sign off for an energy consultant or an energy engineer. So there are tick boxes for, yes, we followed step code for energy compliance, but there are multiple check boxes, one for architectural, one for mechanical, and then for electrical. So none of those consultants are doing the energy modeling. I mean, they could be, but generally not. So to me, I'm not sure if we'll see this in the future, but it seems to me if you have one consultant that is taking the responsibility of taking all that information and then evaluating that for energy performance, that should be signed off by another professional who's responsible for that, rather than having me do the model and then having an architect and a mechanical engineer and the electrical sign off saying that I did my job right. That shouldn't be on them to do that, but that's how it's set up currently. The more typical submission that we see and that we do is we prepare a detailed modeling report outlining how we carried out the models, where the information came from, and the results. And then that's a signed and sealed report as a professional engineer. And so that's the approach we've been taking. And then that's what we've been asked for. We haven't been asked for anything other than that, typically. Sometimes there's some checklists. Yep.
Is that report, are you finding it different templates for different districts, or are they all accepting your summary and that's something you generated yourself?
Yeah, so we're using our own report. It's just like a Word report. It's not like a template Excel form or anything. But what we do see is, in addition to that report, because we produce that either way, both for our clients and for our own records, it's like a nice tidy package of here's what happened. And then what we'll do is there sometimes will be a template, an Excel form, like City of Vancouver. Burnaby has one as well, that you filling out some information. And it's a lot of the same information that we have to transpose over and put in the same boxes. But we do struggle sometimes that some of those forms are poorly done. And you're kind of like square peg, round hole, and you're saying, well, this doesn't make sense. You're asking for this, but no. And we try to provide feedback in those cases to say, hey, your template is could use a little help. This doesn't make sense for this reason, etc. But yeah, we do see that. And I think that makes sense for a building official. Like if I were in your position, I would say, you have to fill out my form so that I can, look very efficiently and look at all the information and they can review it easily. Makes sense to me. But I think one of the challenges there, particularly for smaller municipalities, is where do you have the resources or the expertise to develop that? And I think that's where this provincial checklist is going to be really useful. Yeah.
What discipline as a professional is that you said that the report you submitted, what discipline are?
Well, I did an integrated engineering degree. I'm registered as mechanical, but the whole thing with we're an energy modeling, building performance consulting firm. We're professional engineers. We consult on building performance and all sorts of aspects of it. Not just energy modeling, but there is no category for that. And that's why I'm thinking that maybe there should be, particularly for building energy performance, because if we're responsible for this one requirement, I mean, it could be split up in between all the disciplines, like prescriptively, but when you start moving it to one person, and then I get calls from the architect saying I got to sign this off, but you're the one who did it. And I feel for them because I'm like, well, sorry, you're the coordinating registered professional, so it falls on you. Yeah. So for part 9, my understanding is that, I've tried to get HOT 2000 and make it do things for me, but it wouldn't let me because I'm not an Enercan energy advisor and I have to go do a course. So I haven't done that. I don't plan to, but there are some checks and balances, I suppose, in terms of minimum qualifications for someone who's going to be submitting a HOT 2000 report. You have to, this is right from the Enercan website. You have to pass a foundation level exam. You have to pass your energy advisor exam, and then you have to be affiliated with a service organization. And that's the one I think that would provide me with more confidence than the other two, is that it seems as though they're not just you can't just do your exams and then run away and be like a solo practitioner. You have to be somewhat affiliated with a service organization, which should be licensed, I believe. Andy, do you know about this?
I believe so, yeah, they're qualified, I'm not licensed.
Yeah, you're not qualified. So anyhow, I guess what I'm trying to say is that I remember somebody last year was saying they were concerned that anybody off the street could be submitting their HOT 2000 reports. And that's not entirely true. There's some basic training and requirements to make sure that someone who's producing those reports does have some minimum level of training.
This additional building science course, refrigeration course, and then also they have to have at least, I think it's a minimum of 10 of their performance tasks. Results have to be vetted.
Right, they have to have a review.
Quality assurance before they're actually certified as a certified.
Right. So have you found that you have any concerns? I know you have probably a small group of people that you're used to dealing with and you have a comfort level there, but if you had...
Well, I deal with, there's 3 in my area, I've dealt with all 3 of them.
Yeah.
It's a differences between the 3 of them, how they model a little bit, but I think that should be more standardized. So
Right.
got them all 3 now, they're submitting the same documentation.
But I could see how on a larger municipality you had someone you'd never heard from submitting some things and you'd be like, well, who is this person? Do they know what they're doing? They have it maybe in a different format.
It'd be good to have like a tab at HRC or something where they list all the approved vetted energy advisors you can choose from, kind of like they do with septic practitioners and all these other.
Okay, yeah.
web pages. It'd be nice to have a list of them.
Right.
So you don't just get someone just showing up that's created your own credentials on the printer. You think they're legit and they're producing stuff.
Right. I guess ultimately, once you get more of a database of projects in your municipality, you could, your BS meter is probably getting pretty decent, and you can check the submission and say, does this make sense or not? I think that ultimately that would be the good way to guard against that.
There's going to be a real lack of capacity in 2022.
Yeah. yeah, for part 3 as well, it's there's a lot happening. So additional resources. There are some very good resources. I lose track of them because they're being developed so quickly. We've been involved in developing some of them. So the energystepcode.ca is a pretty good website. They have a lot of information there. If you haven't been there, I would encourage you to go check it out. It's kind of interesting just at the minimum just to see the list of the municipalities that are either have already adopted some step code or are in the process consultation phase, etc. It's we keep meaning to build a map. We think that would be pretty fun to see. Maybe there is one. Is there one already? I don't know if there is. Anyways, it's encouraging to me to see that there is so much adoption of the step code, particularly ahead of the sort of enforced requirements of the planned incremental increases in the building code, because it's a pretty substantial, it's a massive increase in performance, and there's a lot to learn. So I think the municipalities that are taking that on earlier are get a little bit ahead of the game, because the people working in that area are going to be more familiar with it by the time it's required as minimum performance requirements. So yeah, variety of different resources. I guess there's a conference, there's an implementation changes and solutions at 3 to 4:30. There's actually another one at 3 to 4:30. Is this from last year?
I think that the morning one right before this was that session.
Yeah, that's what I was thinking. Okay, but there is one from 3 to 4:30 that I'll be giving, and that is on one of these resources. It's on a design guide supplement that BC Housing retained us to help develop in conjunction with Integral Group and HCMA, and that's going to be about strategies for overheating. Designing around overheating, just understanding it, as well as indoor air quality issues, particularly considering wildfire smoke. And then, yeah, participants will get some follow-up information. Any final questions on that? We're ahead of schedule, so lots of room to chat or have snacks. Yes, Harshan.
You mentioned that you provide energy modeling report. Can you tell me at what point in the process, the building permit stage and then following that, look at the energy performance of the assets, when do you typically issue that?
So typically 3 times. We have a preliminary model. So this is the early stages. It's maybe late schematic, early design development, somewhere in there, depending on the project. Sometimes we don't get hired until it's already well along, so we're kind of scrambling to catch up. But typically we have an early report that is basically outlining the strategy. So this is how we're going to do it, and then the design team can go and actually detail out how that's actually going to work. There may be some interim updates in between there, where maybe as they go further through the design process, the team realizes, well, hold on, actually we don't want to do this for these reasons, or we have a better idea. And so we may update our model in our report then, just to kind of keep track of the design and make sure that we're still on target. Then, actually this is a really good point, Harshan, I'm glad you brought it up, because then at building permit, we submit a building permit model report. But one of the challenges that we've been having with this is timing. We need our report, as I've harped on again and again, we need our report and our model to match the issued for building permit documents. So the old strategy of rush, get me your documents for building permit submission, everyone gets their documents to the architect at the last minute, they bundle them up and submit them. Well, we don't have our modeling report done because we just got the drawings. So what we've been saying is submit the package. Ideally, we're confident, we've kept tabs on the design from preliminary modeling and any changes since then, that we're confident that yes, what they're submitting will achieve it. But we don't actually know that until we've finished updating our model, which will be probably 2 weeks after we receive the documents. So we've been asking that they notify the building official that the energy modeling report will be following in about 2 weeks. And people seem to be behind enough that that's been not too much of a problem, but there is a risk there with, maybe there was something that changed in the drawings that we didn't catch or no one told us about that would be like, actually, no, we're actually not meeting the target. So it's a timing challenge. It's something that we've been trying to be really upfront about with clients because there's some risk associated with that. And then finally, so after the building permit, We wouldn't typically do anything else until the air tightness update.
I also want to let you know that I brought finance development of those professional practice areas, and I will note that the professional assurance schedules where the architectural, electrical, and mechanical disciplines have to check off on a couple of items related to energy code compliance. That would be the best bet in terms of communicating professional assurance. But there's also the requirement in these practice guidelines that the qualified professional who's doing the energy modeling has to make available an energy modeling report that is seen upon request by the AHA. So I just leave it to the AHA so that you know that that will be that asked for.
Okay, any other questions? We got another 10 minutes if we want to just talk.
Just curious if there's been any discussion about, with your climate files, if you're modeling a building that has, say, a 50 to 100-year expected service life, any ways that you can model for predicting future. I know that's difficult to do, but.
No, it's absolutely, there's been a lot of work in that lately, and we're doing that now. So as with most things, it's becoming one of like our sort of minimum services that we like to provide. It's even if it's not being asked for, it's not too much work because we have climate files now. So the Pacific Climate Impact Consortium out of UVic, they've been developing some methodology for morphing weather files to different increments of time. So there's the 2030s, 2050s, and 2080s. And then for each of those, there are also different climate change scenarios. So there's like a sort of a best case, sort of business as usual, and a worst case. So you have a lot of different options, and you can request those files from PKIC. I think eventually they will have like a portal where you can just go and get them yourself, self-serve. Some people are asking us to do that for them already, and in some projects we're providing that just as we think it should be something that everyone should be considering. That the 3 o'clock session we'll be talking about that overheating design supplement. It has some guidance on resources to where you can get that information and how you go about doing that.
I'm just wondering with the air tightness testing, as the non-mechanical systems are built during the testing.
They're sealed off.
They're all sealed.
Yeah.
All cases.
As far as my understanding, yeah, not an expert in that. We've done a little bit, but not too much. So let's say it's a multi-use residential building with in-suite HRVs. Anything that's going to be operating continuously during building operation would be closed off. Even things that aren't, so a commercial kitchen range hood, that would be sealed off as well, even though it's not operating all the time. Yeah, that's our understanding, is that you're evaluating the air leakage of the building envelope only. Even filling like plumbing P-traps, I guess those would be filled when the building is occupied anyways, but generally they're sealed off. Yep, there's it doesn't really matter. You've seen tape and poly and garbage bags, all sorts of things, but there's like a product for sealing off ducts during construction to keep dust and dirt out of them. It's like a single-sided sticky film. They just stick it over top of openings. Yeah, they're pretty good. I think they're pretty good. It's basically like a big sticker you stick over top of it. Yeah, but there could be duct leakage or something. Like if it's as built, like it's constructed, and we're just sealing up the diffuser, well, the duct that goes back to outside, if that's not sealed, that'll have some impact as well. But we can't do that. Any other questions? Lunchtime? Okay, well, thank you very much.